We're now going to look at the case of factorising a general quadratic equation. That is, something of the form ax squared plus bx plus c being equal to the product of two brackets. The first, px plus m, the second, qx plus n. In earlier videos we have dealt with problems where the a is equal to 1, so now we consider the case where a is not 1. This is why we have the numbers p and q in our factors. Our goal is to find numbers p, q, m and n such that multiplying out this right hand side will give us back the left hand side that we started with. If we multiply out the right hand side, px times qx is pqx squared, px times n is npx, m times qx is mqx, and m times n is mn. That's pqx squared plus mpx plus mqx plus mn. We can write this out again and add brackets in to make things clearer. And let's compare to our original quadratic. Notice that m times n is equal to c as before, but now we also have that p times q is equal to a. So we choose our p and q from all possible pairs of factors of a, just like how we chose m and n from all possible pairs of factors of c. However, if we look at what b is equal to, we see that the problem is slightly more complicated than the case where a is 1. We have that b is equal to pn plus mq, so b depends on p, q, m and n. So we must consider possible factors of a, the coefficient of x squared, and also possible factors of c, the constant term, and how they interact in order to give b, the coefficient of our middle term. Let's have a look at an example now. We're asked to factorise 2x squared plus 11x plus 12. Well, we begin by writing down possible factors of 2x squared. We could take that as 2x times x, there's no other obvious choice. So immediately we have that p is 2 and q is 1. What about possible factors of 12? Well, we could have 12 times 1, negative 12 times negative 1, 6 times 2, or indeed negative 6 times negative 2, 3 times 4, or negative 3 times negative 4. As we know that p is 2 and q is 1, we can rule out the product of negative numbers in the factors of 12. Why is that? Well, if we look at our middle term, we see that b should be plus 11. We know that p and q are positive numbers, so there's no way that taking m and n as negative numbers could generate a positive b. So we can immediately rule out our negative factorizations of 12. Now, we should expect some trial and error when solving such a problem. We shouldn't necessarily expect to be able to just write down the answer. So let's try a factorization and see if it's the right one. Let's start with 2x plus 1 or 12 times x plus 12 or 1. This notation I'm using is just a shorthand, and what I mean is that I have a choice of 1 or 12 in the first bracket if I'm considering the factorisation 12 times 1 of the constant term 12. If I choose 1 in the first bracket, I have to put 12 in the second bracket. If I choose 12 in the first bracket, I have to put 1 in the second bracket. Now, let's just look at the top choice first of all, that is 1 in the first bracket and 12 in the second. I don't have to factorise out the whole quadratic, I just have to narrow down to extracting the middle term to see if I've got the right value for b. So that is, I'm going to look at 2x times 12, which is 24x, plus 1 times x, which is x. Add those together and we get 25x, which isn't the correct middle term, so it's not the right factorisation. What about our second choice? What middle term do we get from that? Well, 2x times 1 gives us 2x, and 12 times x, that's 12x. Added together, this gives us 14x, which, again, is not the right factorisation, so we can rule out 12 times 1. Let's carry on trying. What about 2x plus 6 or 2 times x plus 2 or 6? Well, for the first choice, that is 6 in the first bracket and 2 in the second, my middle term is 2x times 2 plus 6 times x, which gives me 10x. And that's not the right middle term. What about the bottom choice? Well, for a middle term there, I get 2x times 6 plus 2 times x which is 14x. Again, it's not the right choice, so neither of these is the right factorisation. What about 2x plus 3 or 4 times x plus 4 or 3? Well, for the top choice, that is 3 in the first bracket and 4 in the second, we have 2x times 4, which is 8x, plus 3 times x, which is 3x, so that's 11x, which is the right factorisation. In other words, 2x squared plus 11x plus 12 is equal to 2x plus 3 times x plus 4. Let's try a second example. We're now asked to factorise 6x squared negative 5x negative 6. We'll start as before with some possible factors of 6x squared. Well, we could have 6x and x, or 2x and 3x, alongside factors of negative 6, which could be negative 6 and 1, negative 1 and 6, negative 2 and 3, or negative 3 and 2. Again, we just have to use some trial and error. So let's try 6x plus negative 6x or 1 times x plus 1 or negative 6x. For our top choice, the middle term is 6x negative 6x, which is 0. And for our bottom choice, that's 1 in the first bracket, negative 6 in the second, our middle term is negative 36x plus x, which is negative 35x. Neither of these is the right factorisation. What about 6x plus negative 1 times x plus 6, or 6x plus 6 times x plus negative 1? Well, for our top choice, the middle term is 36x negative x, which is 35x. And for the bottom choice, the middle term is negative 6x plus 6x, which is 0. Neither of these are right, but also notice that they're the negatives of the previous combination we tried. In fact, it will always be the case that if we try one pair of factors and they give us some value for b, then the negative of those factors will give us the negative of that value for b. So, if one pair of factors doesn't give the right factorisation, then the negatives of that pair will only work if the value for b we obtained is the negative of the actual value for b we need. Otherwise, there's no point even trying the negatives of the original pair. Let's move on and try 6x plus negative 2 or 3 times x plus 3 or negative 2. For the top choice, our middle term is 18x, negative 2x, which is 16x. And for the bottom choice, we have negative 12x plus 3x, which is negative 9x. Neither of these are right, and so we can also rule out trying 6x and x with negative 3 and 2. How about 2x plus negative 3 or 2 times 3x plus 2 or negative 3? Well, for the top choice, our middle term is 4x negative 9x, which is indeed the negative 5x we were looking for. So we have that 6x squared negative 5x negative 6 can be factorised as 2x minus 3 times 3x plus 2.